Hello, you and I are about to go on an adventure. We are going to do some vibe coding together. Now, I've previously posted one of my 90-second explainers about what vibe coding is, but personally, I find it so thrilling that I think it's worth a much longer demonstration. So that's what we're going to do today. In a nutshell, then, vibe coding is where you describe in English to an AI the kind of software that you want it to produce. It spits out the code. You run the code. Maybe you like it, maybe you don't. Maybe you want to make some changes. And so you then say to the AI, this is good, but can you change this, that, and the other? And then it will update the code and you run that. And maybe then you want to make it more advanced or change something else. You are vibing with it, hence the name. So that's what we're going to be doing. To do that, I've got two windows open here. I've got the Google Gemini AI Studio. So that's the large language model that I'm going to be using for this. There are other LLMs out there and many of them can do code. So that's going to be where I'm going to describe my ideas and it's going to spit out the code. And then over here is Visual Studio Code, which is the program that I'm using, the app that I'm using to run the code that Gemini gives me. Okay, right, let's go. I have no idea how long this video is going to last for, by the way, but I promise you I will chop out all the guff and leave you with just the nuggets. Still no idea how long that's going to be. We'll find out. So this is what we do. I'm going to type into Gemini, let's say create Python code. So Python is a programming language. It's the one I've got installed over here. Create Python code for a game in which you are a mouse being chased around a room by a cat. Everything's about cats in this house. You can thank my 9-year-old daughter for that. And you have to collect 5 blocks of cheese without being caught. Okay, that's it. That's all I'm going to tell it. Click run. Here we go. Now you can see it's thinking. This is one of the really interesting things about Gemini. It starts to describe to itself the kind of things that it's been asked to do and what it's then planning to do. So you can see it's expanding the logic and then it starts spitting out the code just like that. I actually don't know whether this is as fast as it's generating the code or whether it just slows it down to make it look a bit more human and a bit less worrying. But there you go, it's come up with some code just like that. And then at the end, you can see it's also taught us how to play. So use the arrow keys to move the mouse, which is the brown square, collect the yellow cheese blocks and avoid the gray cats. All right, so here's the code. And then I'm just going to paste that code in. And there you can see the code's in there. And now it should just be a case of clicking run. Let's see what we get. Ooh. And then straight away we've got a game. My goodness. Hang on, let's have another go at that. Oh. I mean, look at the level of detail that's in this game already. It's given me control over a red square, which is the mouse. The cat is bigger and grey. It moves slower, so that's fair. It has a count at the top of the screen telling me how many cheeses out of 5 I've caught. But already we have a game which, you know, is fairly playable. Right, okay. So I just want to point out a few things about what's happened so far. If we look at the code over here, you can see that, I mean, I haven't done any coding for about 30 years, but this looks fairly respectable code. It's put comments in there as well. Anything with a hash in front of it is a comment. So there are some comments in there to explain to a human viewer how the code wants. To be honest, I have worked with programmers who don't comment their code. It's a right pain. So this is already doing a reasonable job there. If we look over here, as well as the instructions on how to play, you can also see some suggested enhancements if you want to expand it. So it's suggesting better graphics, So you can use actual images for mouse, cat, and cheese. You can have more complex cat AI to make the cat pause occasionally, give the cat a line of sight, make the cat move slightly erratically, or predict player movement. I don't know whether it's saying that it can do all of these things. Obstacles, here we go. Add walls or furniture in the room. Let's do that. Okay, so I'm going to say add some walls to the room. And away we go. This type of large language model is called a reasoning model. And I think what that means is that it doesn't just blindly follow your instructions just from the text you type in. First of all, it kind of analyzes that and rewrites and expands on your instructions, still in English, that it then reads through. So it's creating a more finely detailed list of instructions from your sort of blathering English at the beginning. And so it's spitting out some code. So I want to just look at its reasoning first of all. Designing wall implementation, it says, I've been thinking about representing walls in the game. I plan to model them as static, rectangular objects. Oh, very nice. Exploring collision logic. It's basically creating a diary of the things that it's either planning to do or has done. Okay, one of the things it understands it has to do is if a player or a cat collides with the wall, it obviously can't go through it, so it needs to have some detection for that. And look, here's an added level of forethought, which I find really impressive. It's going to ensure that the cheese, the mouse, and the cat don't spawn inside the walls, which, if you think about it, could happen if you're just putting some rectangular blocks in the game and doing nothing else. It also says, I slightly reduced the cat speed because walls can make it harder for the player to escape. I mean, it cares. It really cares. Right, paste that in. Off we go. Okay, there we go. Well, we have a game with walls. And that's actually difficult because the cat's caught behind this wall. Do I have to lure it out? Yeah, oh, I lure it out. Make it run around here. Fab. Okay, what should we do next? Why don't we add levels? Increase the number of cheeses the mouse has to collect on each level. Start from 1 on level 1 and increase from there. Again, I'm kind of deliberately being a bit vague and cavalier with my English just to see how far I can push its understanding. Right, let's have a look. What are you thinking, my dear? Analysing level design, defining cheese requirements. Marcus Brigstock, the comedian, would appreciate that. He has very demanding cheese requirements. Big cheese lover. Implementing level transitions, level progression. Okay, from that one sentence, it's understood that I want levels. And so I'm assuming the game we're going to get now won't just finish as soon as you've collected all 5 cheeses. So it's taken its time. That's 47 seconds to spit out its thinking. And I believe I've been told that the problem with large language models to begin with, apart from the fact they were amazing, was that they were simply predictive text. And so they would spit out these words and, you know, it could be nonsense or it could be true. You pay your money, you take your chance. If you give these large language models more time to think before they spit out their answer, they're less likely to make silly mistakes. And so, as I say, it's kind of summarized and analysed and expanded on what it needs to do before it actually then acts on it. So that whole thing probably took about 2 minutes to spit out the code after doing the reasoning and everything. Okay, it's introduced something called a cat speed. So it looks like the cat speed is going to increase per level, all right? It's removed the message that says you win because the game now progresses through the levels it understands. And away we go. Here we go. Okay, so, oh, that was it. I was on Level 1, now I'm on level 2. So you can see that on the top left it has the level number, it's counting the number of cheeses, and it's got the cat speed, 2.1. Okay, so it is going to get harder. Okay, I need to get this cat around this side of the wall. Brilliant. Oof, blimey. You go straight into the next level. I mean, you can't fault it. It's done what I asked. I must remember I'm making a video for you and not just playing Chase the Cheese. Oh, game over. Okay, right, fine. The cat caught you. You reach level 5, press R to restart, Q to quit. This is exactly what you would expect from a human programmer if you were just giving them basic instructions. Okay, next thing to change. Let's change the arrangements of the walls. Let's make them different for each level. Let's see whether it can cope with that. Make the arrangement of the walls different on each level. Just that. I'm working on a function that dynamically generates wall layouts based on the current level. It's good to know. I mean, you've got to remember, this is still just predictive text, okay? But it's on a level that's unimaginably huge, and it really is behaving like a human. Okay, so that's, are we really all real humans, or are you a simulation? I don't think it's possible to tell. I like the way that it is still a sycophant. It says here, okay, making the wall arrangement different for each level adds a nice dynamic element. Thank you. Here's how you can do it, and then it summarizes how it's going to do it. To be honest, not even going to read the instructions now, just going to paste the new code in. This is the problem that I've heard, or one of the problems I've heard with vibe coding, is that I don't need to know anything about coding. I've given my complete trust over to this LLM. If it gets it wrong, I will debug it using the LLM. I'll ask it what the problem is. But if it seems to work, I'm probably just going to trust it. And I'm going to run this code. It could be full of security errors for all I know. Good job, that's not important for a Chase the Cheese game. Let's go. All right, level 1, slow cat and one tiny boring wall. Okay, we've got some slightly more interesting wall arrangements here. I tell you what, it's not an unexciting game. The walls though, am I happy with the walls? The walls are short, so they're not really a maze. I suppose I was imagining more of a, not quite a maze, but something where they really would change the shape of the game. These are just random lines that are in the middle somewhere on the game board. I'm not sure they're creating enough of a challenge. He says getting caught by the cat on level 8. What can we do here? Okay, I'm really going to vibe with it now. The walls don't feel complex enough, or cover enough of the playing field. I'm just going to complain. It's going to have to work out that I want something doing about it. I don't know what's going to happen now. You can imagine me on the phone to a developer going, make the walls more complex. Clunk. I'm busy. Just do it. I'm trying not to use the word please in any of this, and thank you, because I know it doesn't make a difference. But imagine if it did. It's quite easy to code a large language model to actually change its behavior, depending on whether you're polite or not. Oh, what kind of world are we heading towards? These changes should result in levels with more walls that are generally longer and fill up more of the screen, creating more intricate paths and challenges. The randomness will still ensure variety between levels. If you find it too dense or too easy, you can tweak the factor and increment constants, it says. No, you can tweak the factor and increment constants. Blowed if I'm going to do any coding. Okay, so I suppose we've got longer walls. Yep, to be fair, they're more complex arrangements. All right. They're kind of getting in the way. I mean, it has done what I asked, and it does actually make it more difficult. I suppose the problem is it's more difficult for the cat as well. All right. Okay, right. It's getting there. I would like, let's try this. I'd like the walls to be more of a maze. Not a really complex maze, but I'd like some of them to touch each other. See what happens. Wow, look. I'm currently thinking about how to connect walls to create those labyrinthine structures the user desires. It's a shift from the previous approach where walls were mostly isolated. I mean, you can see why they called it a reasoning model. Now it's investigating maze algorithms. It's adapting backtracker for mazes. Oh, I hope I haven't asked it to do something too ridiculously difficult. Okay, this is great direction, it says. To make the walls feel more like a maze where they connect, we'll implement a simple maze generation algorithm. Oh my God. The recursive backtracker depth first search is well suited for this. It creates perfect mazes, meaning all cells are connected and there are no loops. Oh, it's blooming putting a proper maze in. Oh God, I might have asked for too much. Have you ever worked with someone where you or they ask for something and then they or you go above and beyond what you've asked in a really kind of overly complex way, and then you have to say, whoa, pull back, pull back. I think we might have this here. Right, let's see what it says. I feel guilty now. I might have got it to do something that I don't like. Oh my gosh. It's blooming made a maze. Look at that. Oh, crikey. I mean, it's done what I wanted. I mean, it's clearly not going to work as a game anymore because the poor old cat can't solve a maze. I mean, we're kind of working towards a different game now, aren't we? Yeah, but the cat is kind of pointless now. This is actually a maze-solving game. I've got to try and find the cheese. How do I get to the cheese? Oh my gosh, hang on. The only way I can get to the cheese is to go past the cat. All right, that's not what I want. So, let's think about this. Let's tell it the problem. The first problem is that the cat now can't get to me because the maze is too complicated. Also, this now feels like a different game about solving mazes. So let's ditch the maze idea. Simply make walls. I'm getting it to throw away an entire maze algorithm that is just pulled out of its digital backside. Simply make walls, some of which connect with each other to make interesting structures to get around. I feel guilty now. You're right, a perfect maze from a recursive backtracker can indeed make it very hard or impossible if the cat's AI isn't pathfinding. Let's revert from the maze generation and go back to a system of randomly placed regular walls, but with an emphasis on making them more likely to connect or create interesting structures. It is taking everything I say literally, but it's also dealing with my instructions intelligently. I don't think this is going to put proper software developers out of a job, right? Because this is coming up with very simple apps and programs. Can I see it creating really complex system architectures that run whole businesses? Well, I mean, never say never, but kind of feels like you do not want to take the humans out of the loop on that one. But I would never be able to put my ideas into practice. I don't know how to code. And so what I would normally do if I felt passionately about an idea and I wanted it in code, I would have to find a software engineer, a coder, and I would have to pay them. And that's who's suffering right now. So anyone who works on Fiverr or any of those websites where they're just a coder for hire, I think those people have a problem. Right, let's paste some code. Hit play. Oh. All right, we've kind of gone back to what we had before. Oh, okay, hang on, it's a little bit different. I'm not sure we're really getting... Oh, okay, I take it back. Here we are on level 4, and we have some complex wall structures. Can the cat get through that gap? No. Okay, make sure the cats can get through all the gaps. Let's make a major change too. Also, add a scoring system where you get more points for completing a level quickly. Again, being vague. Okay, this is a 2-part challenge, it says. Ensuring cat accessibility. Well, it's 2025. We've got to ensure cat accessibility. Time-based scoring. This involves tracking time per level and awarding bonus points. All right. I just think it's astonishing that I'm giving it really vague instructions and it is expanding on my instructions. Absolutely nailing it every time so far. Well, we don't have buggy code. Come on, hurry up. Right, what have we got? Oh, we have an error. Something has gone wrong. All right, well, this is interesting because this is where we get to debug the code. Right, so something's gone wrong. Okay, this is how I debug Python code created by a large language model. I just copy and paste the error and paste it back into the LLM. There's an error in the code. Here is the response. Paste that in. You sort it out. You are absolutely correct. My apologies. I made a mistake in the border wall creation loop within generate room walls. The borders list was defined as blah, 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 blah. Yeah. Don't give me that, just fix it. Here's the corrected generate room walls function. Sorry about that error. This should resolve the type error. So am I supposed to paste the whole thing in? So that's the bit I'm going to replace. I'm going to copy this. I'm just going to paste it in here. Hope for the best. Okay. It works. I'm kind of liking the wall structure. It's got a time that's counting up on the top of the screen. Oh, missed. How am I going to get past the cat now? Come down here and then I'll go up there. So it's giving you a base score of 50 points for completing the level, and then it's also giving you a bonus score on top of that based on the time it takes to get there. Wow. So I just want to emphasize what's just happened as well, in case you missed it. It spat out some code that didn't work. It had a bug in it. And all I did was I pasted the error report back in to the large language model and said, fix it. It understood the error reports and it fixed the code. So just want to acknowledge that. Base score 50, time bonus 215. Not sure how it's calculating the bonuses, but I'm happy with it. I trust it with my life. And the keys to all the nuclear missiles. What could possibly go wrong? Nah, you can't get me because you're trapped, but actually you're trapped with all the cheeses. So, what have we learned? We're all doomed because these things seem to be able to simulate very, very complicated thinking. From very simple descriptions in English, these reasoning models expand those instructions into things that it can then do step by step. So it's kind of programming itself. Then it's spitting out code. It's doing what we want. And it's able to remember everything that's come before. So when you ask it to make a change, it knows everything that's come before. So actually, I just want to show you something that you get on the side of the Gemini AI Studio. There are a lot of switches that you can turn on and off here. Quite frankly, I haven't got a clue what any of them do. I haven't dared turn them on yet. But up here, you can see the token count. Now, if I understand this correctly, this is Gemini's working memory. So what I think this is saying is it can hold in memory just over 1 million things that have come before. Not quite 1 million words. They're called tokens, and they're kind of bits of words and concepts and things like that. So it can hold up to 1 million before it starts to forget, things start falling off the end. Everything that we've done today has used up 63,000 of those tokens. So you can kind of see how it's going to take quite a lot to fill its brain before it starts forgetting what we talked about at the beginning. I've never filled up or got anywhere near filling up Gemini's working memory capacity. My suspicion is that it's not remembering every word or token that we've had in the conversation. It's somehow condensing what we've talked about into its own notes, and that's what it's remembering. So that's my guess, is that's how it's being more efficient with how it's storing things and how it can remember longer term. But there you go. I know that's been long. I don't know how long yet, because I'm going to do the editing. So, think of me when you're, I don't know, sleeping, having fun. But I hope that's giving you some kind of idea of what vibe coding can be like. And I know that we're only doing a really simple game here. I know that. And I know that doing anything that's really complicated in corporate systems is a completely different ballgame. But my God, right? Isn't it great for just vibing and trying new ideas? If I had a genuinely original idea and I wanted to see how playable it was, I could do it now. So if you've made it to the end with me, congratulations. I hope you've enjoyed what you've watched. And if you have any suggestions on how I could do these videos better in the future, put them in the comments. I'd love to hear from you. You will shape the future of these things. So it's all on you now. I'm great at devolving responsibility, aren't I? Either to you or to the LLM for the coding. For the meantime, yeah, I'm just going to start chasing the cheese until I'm dead. Which is surely a metaphor for life, don't you think? Come on, can I get past level 8? Ooh. All right, you stay there. Gotcha. Oh no, I'm trapped. Okay, I'm going around here. Oh no, how am I going to get that cheese? Oh, maybe I can trap it. I'll trap it round here. Gotcha. Gotcha, gotcha, gotcha. Oh. Oh gosh. What am I on? Level 7. Level 7, and I've got a cat just the other side of the wall. Oh no! I bottled out. Come on, this way. That cat is getting faster. All right, let's think about this. I'm going to get all this cheese first. Now, how am I going to get past this? Oh, yes! Oh, look at that. Like, poor cat, trapped in a room. And there's me just hoovering up the cheeses. So you can see the walls are getting more complicated. Oh, it's not guaranteed that I'm going to run rings around the cat. Oh, God. Right, how am I going to get that? Can I trick it into coming this way? Oh, it won't fit. So there's an example of where it can't fit through the gap. Come on then, you come this way. Come on then. Come on, we'll go the long way around. Like Clara. Level 11, oh my God. This is actually a bit brain busting. All the cheese is over with Pusscat. What am I going to do now? I'm just going to run for it. Get him round here. Oh no! Ah! Got stuck!